Welcome everyone. Today we are going to look at a different type of classifier called the nearest neighbor classifier. So the nearest neighbor classifier, how it works. The classifier identifies an object based on its neighbor. For example, consider that we have a group of fish over here and we have a group of snakes over here. And in the middle of these two we have an unknown object. And all I know that this object has either to be a fish or a snake, but I don't know that who it is as it is unlabeled. Now based on this nearest neighbor classifier, all that I have to do is that to classify this unknown object in either of these two groups. So let's start by looking at its nearest neighbor. So if I look at its nearest neighbor, it turns out to be a snake. And well, based on that, probably I might think that since its nearest neighbor is a snake, it is also probably a snake. Well, it's not advisable to stop like that. We can also go and see if its two nearest neighbor, which turns out to be a fish and a snake. Now this turns out to be a tie. So let's go ahead and see another neighbor, and it turns out that its nearest neighbor includes two snake and a fish. And going in this way, its four nearest neighbor includes three snakes and one fish. And so based on this data that we discovered right now, this object, since three of its four neighbors is a snake and one of them is a fish, then this object is probably a snake and not a fish. So this is the basic idea of the nearest neighbor classifier. Now consider a data set. In this data set, we have the information of two numerical variables, height and weights, and each of these observations are labeled either obese or overweight. Now understand one thing, that in the multivariate analysis, each example is represented as a data point in d-dimensional space, where d is the number of attributes. For example, we have heights and weight over here, so this observation, each of these observation, obese, overweights, they can be represented uh, as a point in the two-dimensional plane. So in this data set, we got six observations which are labeled as obese, and the rest of the six are labeled as overweight. Now, if I am given a new data containing height and weight, and I'm asked to classify that it's an obese or overweight. Now here, understand and assume that we do not know how to calculate the body mass index, and all that we have to do, we have to classify based on the information given in the data set, and we have got no extra informations, and we don't know how to calculate the body mass index. So one thing we can do is that we can plot these points visually, and let's see that how this visual data looks like and where this point is located in that two-dimensional space. So this is the visualization of the previous data set, and see that each of these points actually represents an observations with its this graph has its x-axis as heights in feet and its y-axis at weights, and these observations are those observations in the data set. Each of these gray dots represents an overweight person, and each of these yellow dots actually represents an obese person. Now see, amidst of these we have a red circle, and which is not colored as yellow or gray but is unlabeled, our new data set, and all that I have to do is that we have to classify it as either obese or overweight, and we have to do it based on the nearest neighbor. So we will start looking for the nearest neighbor, that who the nearest neighbor of this new data set, and we see that it's actually an obese. Well, the nearest neighbor to this new data is an obese. So Based on this information, probably we can think that it's likely that this new data set can also be labeled as OBs. But before we take any conclusion, let's go one step ahead and see that what 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 the two nearest neighbor includes. So if I consider the two nearest neighbor, we can see that it includes one obese and one overweight, and so it's a tie. So it can be either one of them, or an obese or an overweight. To avoid the confusion, let's go one step ahead and look at the three nearest neighbor. And if I see that three nearest neighbor, it includes two overweights and one obese, indicating that this new observation is more likely to be overweight compared to obese. And if I go one step forward for 4NN, I start looking at the four nearest neighbor, and I see that now it includes three overweights and one obese, and thus beating completely the probability of being obese. And so now I can classify this new data set, the new observations, as overweight based on his four nearest neighbor. So this is how it works. Now let us look at the kNN algorithm. The kNN algorithm can be summarized as follows. A positive integer k is specified along with a new sample. We select k entries in our database which are closest to the new sample. We find the most common classification of these entries. And finally, this is the classification we give to the new sample. So this is the algorithm by which the k nearest neighbor procedure, the concept works. Now, an important question and most necessary question that we must ask here is that how to choose the value of k. Now, if k is too small, then the nearest neighbor classifier may be susceptible to overfitting because of the noise in the training data. For example, look at this figure. We can we can clearly see that there are mainly two types of object, the one represented by these yellow dots and the other represented by these orange squares. And it happened that due to noise in the sample, some one of these orange square got misclassified as these yellow dots, and also that it happens that the new observation represented by this star happened to fall very near to this noisy sample only. And if I have considered only the one nearest neighbor, the 1NN, then it got misclassified. The new sample got misclassified as a yellow dot. But I can clearly see that if I take 2, 3 or 4 nearest neighbor, then it's more likely that the new data will be classified as an orange square. On the other hand, if k is too large, the nearest neighbor classifier may misclassify the test instant because its list of nearest neighbor may include data points that are located far from its neighbor. Usually, a value between 5 to 10 is taken as a reasonable value of k. The kNN The k nearest neighbor classifier is also known as a lazy learner. Now there are mainly two types of learner. One is an eager learner and one is a lazy learner. Classifiers such as logistic regression model, decision tree and rule-based classifier are all the examples of eager learner because they're designed to learn a model that maps the input attribute as soon as the training data is available. Whereas the lazy learner such as kNN classifier delays the process of modeling the training data until it is needed to classify the test example. We have seen in the k-nearest neighbor classifier problems that it actually does not involve a model. So we do not feed the data to build a model and a generalized model that when given a new test data uses all its experience and expertise to predict the result. It delays the procedure, it waits until it is needed to classify the test examples. There are multiple applications of these k-nearest neighbor classifier concepts. Um, like credit rating and multiple and many classification problems, and one of the most important, one of the very important uh, place where it plays a very good role is in imputation of missing values. So in the upcoming videos we are going to see that how we can use these the concept of kNN for the imputation of missing values. So hope you enjoyed. Thank you. Bye.